Hey everyone, welcome back to the next section. Today we're going to be going through some ideas on periodic trends. So there's a few different ones that are here, as well as a little video at the end that you could watch to hopefully just kind of give a little recap on it just from a different perspective. So when we start to talk about trends in atomic size, what we're going to take a look at is if we were to look from top down on the periodic table, going down our columns or maybe going across our rows, what is the general trend that occurs? And we'll take a look at a few different ones. So atomic radius is first. The atomic radius is 1/2 of the distance between the nuclei of two atoms of the same element when the atoms get joined together. And so these two atoms that can get joined together, there are 7 real different ones that are here. We call these ones diatomic molecules. They form compounds with themselves. And so if we were to take a look and kind of where they happen to be, the 4 that are on the bottom happen in our halogen group, and then really from the top part going across for nitrogen and oxygen, and then number 1 for hydrogen. So if we were to take a look at the distance between the two nuclei, then we can start to see kind of what this radius value is saying, right? 1/2 of the distance between two nuclei. And so if we were to look at these numbers, you can probably follow on the table and get a general idea of what the trend is going to be. So going from left to right and top to bottom looks like it would kind of increase along the way. So as the elements move down a group, the atomic radius increases, so it increases in the number of orbitals in each energy level. So an increase in orbital would obviously make its size larger, and so would then increase its atomic radius. And so as the elements move across a period, the atomic radius generally decreases, and so the energy level stays the same in a row. Okay, so as they move across, we get this kind of decreasing trend. As they move down, we get this increasing trend. Trends in ionization energy. So the energy required to remove an electron from an atom is called its ionization energy. It's measured when an element is in a gas state, and the first ionization energy tends to decrease from top to bottom within a group. There's less force of attraction from the nucleus, and it increases from left to right across the period, where we have a stronger force of attraction from the nucleus. Okay, so ionization energy, the energy required to remove an electron from an atom. Okay, how much energy is required to take an electron out of an atom? So there's multiple ionization energies because we have multiple electrons that could be taken out of an atom. The closer it starts to get toward the nucleus, the more energy is going to be required. And you can have first, second, third ionization energies. For our purposes, we're really going to just focus in on the trends for the first ionization energy, although they do follow pretty similarly. So this increase left to right, we get the stronger force of attraction from the nucleus because it takes more energy to pull them away. We get a decrease from top to bottom because we're gaining in orbits or orbitals. And so as the size increases, the electrons are getting further away from our nucleus, and so less energy would be required. So in general, we get an increase in energy going left to right, and we get a decrease in energy going top down. So the next trend is trend in ionic size. When metals form compounds with nonmetals, we get these metal atoms that tend to lose electrons. We call those cations, while nonmetals tend to gain electrons. We call those anions. Cations are always smaller than the atoms from which they form. And the reason being is that they lose electrons, and so if we were to picture how these orbitals work or how these shells work, as they lose electrons, they start to go down in energy level or down in orbit, and it's going to cause them to be smaller atoms. Whereas anions are always larger than the atoms they form because they tend to gain electrons, so they get a little bit larger. So in general, as cations and anions move across the period, they decrease in size. And as anions and cations move down groups, they tend to increase in size. Next we have trends in electronegativity. So electronegativity is the ability of an element to attract electrons when the atom is in a compound. I'll kind of zoom in just a little bit on this, just make it a little bit larger. So electronegativity, ability of an element to attract electrons when an atom is in a compound. So attraction of electrons. So in general, electronegativity values decrease from top down within a group because they get further away from the nucleus. For representative elements, so our group A, the values tend to increase from left to right across a period, and that's because they're closer to the nucleus. So in general, we kind of get this idea where electronegativity increases going left to right and increases going bottom up. And so we get this general trend going diagonally toward fluorine. Keep in mind here, our noble gases realistically are fairly stable because they have full shells already for their electrons and don't really tend to react very much. So really fluorine here would be one of our most reactive elements that we have. So there's a summary of trends that are here, and you are free to copy this trend table on your periodic table on the back to have it for any quiz or test that you may need it for to reference. So you don't need to memorize the trends, but more to be able to understand how to use them. Okay, there's also a video that I'll post on the website as well that you should watch just in terms of a little recap. Again, just a different way of looking at it in terms of somebody else explaining the trends and just kind of going through some of the characteristics. So the last thing, there are a couple of questions that are on page 178 and 181. And in order to answer some of those questions, you might need to go into the second and third ionization energies. And so there's a little table on page 173, table 6.1 for you to take a look at. So go through, just have a general understanding of how these trends work and try to gain a sense of how you can order them from like least to greatest or biggest to smallest based on what it might be asking for. So good luck.